In this video, we are going to begin Chapter 1, Section 1 on lines and angles. We have two objectives. We're going to identify parallel, perpendicular, and skew lines and parallel planes. And we're going to also identify the angles formed by two lines and a transversal. Two lines cut by a transversal, I'll probably say most often. Lots of vocabulary, but as you'll see, these last ones corresponding alternate interior, they all have to do with two lines being cut by a transversal. And you'll get to know these really well. All right, here's our first vocabulary. Parallel lines can be represented by two up and down lines like that. They're coplanar, so they lie in the same plane, and they do not intersect. So in this figure, line AB is parallel to line EF. Also, line EG, which is right here, is parallel to FH. And there's other parallel lines in this picture, but that's just a couple of them. Perpendicular lines, the symbol looks like an upside-down T, intersect at 90-degree angles. In the figure, line AB, where's AB? AB is up here, is... Get my pen here, my laser pointer. So AB is perpendicular to AE. Now we know that because there's a 90-degree right angle mark in the corner, not necessarily that they look like 90 degrees because it's drawn 3D. Also, EG is marked perpendicular to GH, and those ones even look like it, 90 degrees. Skew lines, that's probably a new one for you. Skew lines are not coplanar. So you have to have two lines that don't lie in the same plane. They're not parallel, they'll never intersect. In this example, line AB and EG are skew lines because they're in two different planes. They'll never intersect and they're also not parallel. And then parallel planes are planes that do not intersect. Like think about shelves in a bookshelf. For example, and remember we name a plane by 3 points in the plane. So plane ABE, that's kind of this top shelf here, would be parallel to plane C, where's D? CDG, but I don't see D. I think D is supposed to be over here, because then they'd be parallel. Arrows that are used to show that AB is parallel to EF and line EG are parallel to FH. All right, next, remember that segments or rays are parallel, perpendicular, or skew if the lines that contain them are parallel, perpendicular, or skew. So it doesn't have to just be lines, it can be segments or rays as well. So your problems for this is just going to be identifying. So if you have to identify a pair of parallel segments, there's lots of different ones. One example would be LM is parallel to QR, segment LM parallel to segment QR, but there's many, many other ones. An example of a pair of skew segments would be KN, which is back here, and PQ, which is on the back side of this box here. A pair of perpendicular segments might be NS. This one is perpendicular to SP. They're marked perpendicular. And a pair of parallel planes, plane NM, where's R? R, that's this front side of the box, would be parallel to side or plane L or KLQ, which is the back side of the box. This is just some more examples if you want to pause the video and try them and then come back and check your answers. A pair of parallel segments could be, this is just an example, BF to EJ. A pair of skew segments could be segment BF and DE. A pair of perpendicular segments could be BF with FJ, and a pair of parallel planes could be plane FJH, that's the bottom part of the box, with plane BCD, which is the top side of the box. Okay, some more vocabulary here. These are very important. You want to make sure that you put these in your notes with some examples, like this sketch would be a very good thing to put in your notes. Okay, first of all, transversal is just a line that intersects two other lines. Okay, so you've got two lines and then a transversal cuts through them. When that happens, many special angles are formed. Now, in the next section, we'll learn what happens when the transversal cuts through parallel lines. That'll be even more special. But first, we'll learn the names. So, corresponding angles lie on the same side of the transversal and on the same side of the two lines that it cuts. For example, angle 1 and angle 5 are corresponding. They're on the same side of the transversal, and they're both like above their lines. So they're both above and to the left. Another pair of corresponding lines, because there's many of them, and usually you'll just get to pick whichever ones you want. Another pair of parallel lines would be angle corresponding 2 and, let's see, angle 2 would be corresponding with angle 6. But there's even other ones. You could do angle 3 and angle 7, or you could do angle 4 and angle 8. So there's lots of different options there. Okay, then we have alternate interior angles. Note the word alternate. That means on opposite sides of the transversal. And they're interior, so they're going to be between lines R and S. So we only have lines, or angles 3 and 6 would be alternate interior. And the other option, the only other one that we could have would be angle 4 and 5. That's my and symbol for today. Alternate exteriors are also on the opposite sides of the transversal, and they are outside of the two lines that the transversal cuts through. So angle 1 and 8, see angle 1 and 8, or angle 2 and 7 would be the other option. Angle 2 and 7. And then the last one, some books will call this same side interior, some will say consecutive interior. They're on the same side and also in between. So they're on the same side of the transversal, and they are in between the two lines. So angle 3 and 5, or you could have angle, let me get my eraser here, erase all these marks, or angle 4 and 6 would be the other option. So you could either have angle 3 and 5 or angle 4 and 6. Oops, sorry. See if there's anything else. Nope. Okay, so here's an example for you to try. We have that an example of corresponding angles. Well, corresponding is on the same side of the transversal. So we could do angle 2 and angle 6, or we could do angle 3 and angle 7, or we could do angle 1 and angle 5, or we could do angle 4 and angle 8. There's many different choices, especially for corresponding. And then the next one says alternate interior. There's not as many choices for alternate interior. We have to pick opposite sides of the transversal, and they have to lie inside the line, so in this region here. So we could do 3 and 5, or we could do 4 and 6. Those are our only options for alternate interior, not as many. And then our next option, or the next one to alternate exterior, again, not as many options for that one. We could do 2 and 8, because they're opposite the transversal and outside of the lines, or you could do 1 and 7. And same side interior, we could only do 3 and 6, or 4 and 5. Those are our only choices there. And if it says to give an example, you only have to find one. This is for you to do some extra practice. If you want, pause the video, try it out, and then check your answers. An example of corresponding might be angle 1 and 3. An example of alternate interior might be 2 and 7, or you could do 3 and 6. An example of alternate exterior angles might be angle 1 and angle 8, or you could do angle 4 and angle 5. And same side interior would be angle 2 and 3, or angles 6 and 7. Okay, so sometimes it's a little tricky, especially if you have more than 3 lines, to tell which one is the transversal. So what we want to do is find the line that connects the vertices. All right, so see, there's all these lines kind of overlapping. Well, which one's the transversal and which one's the angles? So the first thing to do is look at the angles. Angle 1 is right here, and angle 3 is over here. The transversal is the line that cuts through both of them and kind of connects them. That's the transversal. So that means the other two are the lines. So then you can tell, well, they're not both inside, so they can't be interior. They're not both outside, so they can't be exterior. So it looks like these are corresponding. The transversal is line L, and their corresponding angles. Okay, so now let's look at angle 2 and angle 6. Here's angle 2, and here's angle 6. So the transversal is the line that attaches them to each other. Okay, so that means the other two lines are the lines that are cut. Okay, so now we've got one on one side of the line N and one on the other side. And they're both inside of their lines. So the transversal is N, and they're alternate interior angles. Okay, one more example here. Find angle 4. Here's angle 4, and here's angle 6. So the transversal is the line that attaches them to each other, that touches both of them. So the transversal is M, and that means that the lines are L and N. This time it looks like they are on opposite sides of the transversal, so alternate, but instead of being inside, they're exterior angles. So the transversal is M, and they're alternate exterior angles. This is for you to practice, so you can pause the video, try this, and then check your answers. Okay, so they just asked you to identify angle 2 and 5, which is here and here, which means that this is the transversal. And these are on the same side, so the transversal is N, and they're same side interior angles. Okay, so that is it. This is a short lesson, and hopefully you won't have any trouble with it. If you do, please let me know. Thank you very much.